Well, hi there. Today we're going to talk about Lesson 57. And Lesson 57 involves negative exponents and scientific notation for small numbers. We always start out with just a little bit of vocabulary, but today, instead of actually writing a definition, I'm going to show you. Scientific notation looks like a number like this. It's a decimal number with only one number to the left of the decimal, times 10 to some power. Now, we're also going to talk about something called standard notation. Standard notation looks like this. In other words, the standard way you would see the number on an everyday basis. Another example, okay, we have scientific notation here, standard notation here. Notice the way we got from here to here is to simply take the 7 and go, move the decimal 1, 2, 3, 4, 5, 6, 7 places to the right. Hence, we have standard notation. Notice that all of the powers of 10 in these examples have positive exponents, so the decimal always is moving to the right. Now, that's not always the case. For instance, sometimes we want to write negative exponents with our powers of 10. So here's one right here. 6.5 times 10 to the negative 4. Now, when it was a positive, we went to the right. So, when it's a negative, let's do the opposite and go to the left. So to write this scientific notation, we find rather than moving to the right, we will move the decimal to the left, or in a negative direction. So 6.5 times 10 to the negative 4 is going to show like this. Put your 6 and your 5 there. You start where the decimal is, so you'll start right here, and you'll go 1, 2, 3, 4 to the left, and fill in those holes with 0 placeholders, and this is your new decimal. It's not too hard, is it? I didn't think so. Okay, let's take a look. So, anytime that we're working with negative exponents and powers of 10, we will simply move the decimal to the left. So here we go. We got scientific notation. We have standard form. Write these in your notes so you have examples. Scientific notation, standard form. Get to be pretty small numbers. Scientific notation, standard form. These kind of numbers you'll find used a lot in science, measuring the size of an atom or smaller, or nanoseconds, and things are really small. Okay, now we also have negative exponents that are not used with powers of 10. This requires the expertise of flipping. Are you ready? Sure you are. Okay, negative exponents that are not powers of 10. Here we go. 2 to the negative 3. Let's put it in the basement and have 1 over 2 to the third. And that's 1/8. Let's try it again. Okay, so the number that goes to the basement, if it's not there to begin with, and I'll show you one that's not there to begin with, and the exponent becomes positive. So 2 to the negative third, 2 goes into the basement, this exponent becomes positive, and then you go ahead and do the work, do the math. Here's another one. 3 to the negative 2, 3 goes to the basement, the 2 becomes positive, 3 times 3 is 9, and you have 1/9. 4 to the negative 2, 4 goes to the basement, it's 1 over 4 squared, 1 over 4 squared is 1/16. Sorry, I didn't show that very well, did I? Any questions? Okay. Okay, so what about if the number with the negative exponent's already in the basement? Well, math is a funny thing. We just do the opposite that we were doing before. We'll flip it to the top. So, what if we have 1 over 2 to the negative 2? Well, it was in the basement, so it's going to go upstairs. And it becomes 2 squared. 1 over 3 to the negative 3. 3 goes upstairs. It's cubed. Becomes 27. 1 over 2 to the negative 4 goes upstairs. 2 to the 4th is 16. 7 over 2 to the negative 4 is 7 times 2 to the 4th, which equals 7 times 16, which is 112. Now, challenge problem. Ready? What about these powers? 4 to the 1st, 4 to the 0, and 1 million to the 0. I challenge you to figure out what these are. Submit them for bonus points. And that's it for the day. Thanks a lot. You have a great day. Talk to you later.